going to introduce a very important result in algebra just by looking at these three examples here. Starting with the first one, if I expand those brackets, I'm going to get x times x, which is x squared, x times negative 4, negative 4x, 4 times x is positive 4x, and then 4 times negative 4 is negative 16. So that was positive 4 multiplied by negative 4. If I now simplify that expression, I'm still going to get the x squared, but negative 4x plus 4x is just 0. Those two pretty much cancel out completely, so they're gone. And I'm just left with the negative 16. If we compare that first expression to the second expression, they have something in common. We have the same number in both brackets, and in one bracket it's a positive, and in the second bracket it's a negative. If I try expanding this one again, I get x squared, subtract 7x, add 7x, and positive 7 multiplied by negative 7 becomes negative 49. And now again, if I try to simplify this, negative 7x and positive 7x are just going to cancel out, they're going to add up to 0. So I'm just left with x squared subtract 49. In this final example, the only difference is now the coefficient of x is bigger than 1. So we can see a number written in there. But importantly, it's the same number in both brackets. And we have the same constant term in both brackets. And again, one of them's positive and one of them's negative. And so now if I expand the brackets here, I'm going to get 3x multiplied by 3x is 9x squared. 3x multiplied by negative 9 is going to be negative 27x. 9 multiplied by 3x is going to be positive 27x. And finally, positive 9 multiplied by negative 9 is going to be negative 81. Just like we saw in the previous examples, those two middle terms, negative 27x and positive 27x, are going to cancel out, just leaving 9x squared subtract 81. Now what's really interesting about these three expanded expressions in blue is that in every single case, every number is a square. 16 is a square number, so is 49. That should be 81. There we go. 81 is a square number, and also 9 is a square number as well. And actually the coefficient of x squared here and here is 1, and 1 is also a square number. 1 squared is 1. And even x is a square number because we have x squared there, x squared and x squared there as well, so that's also a square number. So in each expression we have two terms. That term and that term are both squares. So are those two, and so are these two terms as well. And in each case we find that we're taking the difference between each square. When we subtract two numbers, we say that we're finding the difference between them. Why is that important? It's important because this result, which is very special, gets the name the difference of two squares. So that's just something that's being noticed and observed and recorded in mathematics. But in the next video, we're going to look at how we can use our knowledge of this result to very, very quickly, almost instantly, factorize expressions that look like that.